So let's take a look at some molarity problems. So a couple of things. Molarity is moles over liters. And basically that means moles of solute over liters of solution. The solute is always the one in a lesser amount. So for instance, say I have 6m HCl. So that M means molarity. Or molar. You can call it molar molarity. More importantly is I'm going to write this as a unit factor. So 6m HCl, I'm going to write it as 6 moles of hydrochloric acid over 1 liter of solution. Or I can write 1 liter of solution over 6 moles of HCl. So again, I like to write these molarities as unit factors. So a couple of things. Let's take a look at this right here. It says how many moles of 6m HCl in 255 milliliters of solution. So the 6m, I write that as a unit factor, so I'm not going to write that down first. So again, we go through our general template, what's given, unit factor, etc. So the what's given is going to be 255 milliliters. Whenever you deal with molarity, convert that to liters. So 1,000 milliliters is going to be 1 liter. This is 1 liter of solution. I need to end up with moles, so I'm going to use unit factor 8. My liters of solution cancel out. I'm left with moles. And when I do that, I'm actually going to end up with 1.53 moles of HCl. I'm not going to care how you round that off, that final answer. Just take a look at the second one. It says how many grams of lithium carbonate in 150 milliliters of 0.25 mole lithium carbonate solution. So a couple of things with this one. Again, whenever I get the concentration and molarity, so this is right here, write it out as a unit factor. Just go ahead and do that. So that's 0.250 moles of lithium carbonate per 1 liter of solution, and then 1 liter of solution over 2.50 moles of lithium carbonate. Again, don't write that down first. Again, with these problems, you have to decide what do I write down first, second, etc. So go ahead. Let's write 150 milliliters first. So that's going to be our solution. Let's convert that to liters. So 1,000 solution. Now that I got liters of solution, I can go to moles. So I'm going to use unit factor 8. We need to end up in grams, so we're going to use the molar mass, just like we've been doing before. So 1 mole is 73.89 grams. Again, we're just converting now. We're from moles to grams. So I do that, I'm going to end up with 2.77 grams of lithium carbonate. So again, when you're doing these, don't write down the concentration first. Use that as a unit factor. So the only other number I had was 150 milliliters. So I wrote that down first, convert to liters, go from liters to moles, and then moles to grams. Again, work out step by step by step. Let's take a look at the very last one. In this case, what is the molarity of a solution in which 15.25 grams of aluminum hydroxide, so this is our solute, is dissolved in 200 milliliters of solution. So solution is the total volume of everything in there. They gave it a molar mass of aluminum hydroxide. So a couple of things with this. Molarity, remember, is moles of solute over liters of solution. So I need to get the moles of aluminum hydroxide. So I have 15.25 grams. Let's convert that to moles using the molar mass. So when I do that, I'm going to end up with 0.1955 moles of the aluminum hydroxide. I need to get liters of solution. Well, I have 200 milliliters. That's my solution. A quicker way of doing this to convert it to liters is move the decimal over 3 places. So 1, 2, and 3. So liters. When you do that, I'm going to end up with a concentration now of 0.1974 moles per liter. So basically, I need to get my moles of aluminum hydroxide. I got my grams, convert to moles like we're always doing, and then divide it by the volume in liters.